Dear students, in this video, we are going to discuss about the AC circuits which contain inductance only. But the question is, what is inductance? Well, it's the property of coils, the solenoids, and in electromagnetism, we have studied that whenever the magnetic flux linked with the coil changes, then what exactly happens? There is an induced EMF in the coil, and the EMF is induced in such a manner so that it can oppose the change in magnetic flux. This we had studied in electromagnetism, and it's one of the Faraday's laws also. So, suppose you have an inductor here. Suppose you have an inductor here, and that inductor is connected to a battery, to the two terminals of the battery. Now, what is the story which is going to unfold afterwards? This battery is a DC source, right? What is going to happen now? You have a key also here. When the key is pressed and the current starts developing inside that solenoid, then that current will change the magnetic field of the solenoid, right? Because B is equal to mu naught Ni. That magnetic field will change the magnetic flux linked with the coil, because flux is BA cos theta. Now, when the flux changes, there is something which happens in this coil which will try to oppose the change in magnetic flux. And how it will oppose? By inducing an EMF in itself. Okay, so that EMF is known as back EMF, and it is equal to minus d phi by dt, right? So this is something that you have studied so far. But now we are going to discuss something different, that if this battery is no longer there and this battery is replaced by an AC source. I repeat, battery is a DC source. It generates direct current, a current which flows in only one direction. So the situation, the scenario is different when the current flows in only one direction and when the current flows in a fluctuating manner. These two are different situations. Please try to understand this. Now you have replaced this DC source by an AC source. The inductor is still there. अभी जानना ये है कि अब क्या होगा इस इंडक्टर के साथ जब आपने AC सोर्स से रिप्लेस कर दिया है. So that's the target now. So let's study, since this AC source is there. So at an instant of time, if this is positive, this is negative, suppose what is the EMF provided by this source? That will be E is equal to E naught sine omega t. Now you can see the name of the topic, AC circuits containing inductance only. So we are considering that it's a pure inductor. Only the windings and the coil is there. But actually, practically I am telling you, even these windings also have some resistance capital R. So actually में pure inductance कुछ नहीं होता है. Okay? Inductor has a resistance also. It's not that you have just connected pure inductor. But we are considering that resistance to be of negligible amount, and we are thinking that this circuit contains inductance only. It's just the ideal consideration, right? So suppose when the current starts flowing in this circuit, the alternating current starts flowing in the circuit. Earlier it was not flowing, but then it started flowing. Suppose it took dt time to develop. The current took dt time to develop. What will be the change in current? That will be equal to di by dt. Okay? By the property of self-induction, you know that phi is equal to Li. Phi refers to magnetic flux. L is self-induction. I would see, if you're not relating with this, you can see the video of self-induction. Self-induction is the property of the coil by virtue of which it tries to oppose any change in its magnetic flux. So whenever the current flows, the coil has a flux equal to Li. So phi equals to, now how can we see this? E is equal to minus d phi by dt, back EMF. So E is equal to minus d by dt. This is the induced EMF, which will try to oppose the cause, this change in magnetic flux. So this will be minus d by dt Li. This will be E is equal to minus L di by dt. So this is the EMF. This is the back EMF, induced EMF, right? Now this negative sign indicates that the induced EMF opposes the change in the magnetic flux. Now what happens? Suppose if the induced EMF occurs, okay, if the induced EMF is there, so it will try to oppose the current. When it will try to oppose the current, what would that mean? That would mean that the current flow will be hindered. When the current flow will be hindered and you want to maintain the flow of current, you would have to apply the EMF at least equal to induced EMF. Induced EMF try कर रहा है कि वो करंट को फ्लो ही नहीं होने दे. तो अगर आप फिर भी करंट को फ्लो करवाना चाहते हो तो आपको कम से कम उतना ही तो सोर्स मेंटेन करना ही पड़ेगा जो इसको अपोज कर सके. So the applied EMF is equal and opposite to the back EMF, induced EMF. What is the applied EMF? That is capital E. It should be equal and opposite to the induced EMF, minus E, if you want to maintain the flow of current. So E is equal to minus L di by dt, right? So this will be E is equal to plus L di by dt, right? After that, you can see here how the situation is. Di is equal to E upon L dt. Okay, so what is going to happen next? I'll explain here. Di equals to E naught sine omega t divided by L dt. If you will integrate it, di equals to E naught sine omega t by L dt. Try to integrate it. It will become I equal to E naught upon L, बाहर आ जाएगा, sin omega t dt. So I is equal to E naught upon L. What is the integration of sin omega t? It is minus cos omega t upon omega. And since there is no limit of integration, so there is a constant also, plus C. So let me copy this equation to the next page. So this is the equation of current. Now I is equal to minus E naught cos omega t upon omega L plus C. So this constant will also have the dimensions of current, because according to the addition law, we know that only like quantities can be added. Current will be equal to current plus current. Okay, because length plus length is equal to length. Meter plus meter is equal to meter, not kg. So according to that, this is also current. So if this is current, so this means this is also time independent, because current is time independent. So after that, this constant comes out to be 0, because EMF oscillates symmetrically about 0. It goes from 0 to minimum, from 0 to maximum. So this constant becomes 0. So what we are left with, I is equal to minus E naught upon omega L cos omega t. So I will be equal to minus E naught upon omega L. Can't you write cos omega t as sine pi by 2 minus omega t? Because sine 90 degree minus theta takes you to first quadrant. Sine 90 minus theta is equal to cos theta. So applying that, I can also write this situation vice versa. Cos theta is equal to sine 90 degree minus theta. 90 degrees pi by 2 only. So, but you might be thinking why I have done that. Because E is equal to E naught sin omega t. ये आपने शुरू में सोर्स अप्लाई किया था. So that equation had the form of sine. But this equation was having the form of cos. So I had to convert it into sine so that I can compare the equations of current and voltage. If you have seen my previous video where I showed you what will happen when AC circuits contain resistance only, there you saw that if voltage applied was E is equal to E naught sin omega t, then current was also coming out to be I is equal to I naught sin omega t. जहां से मैंने आपको बताया था कि दोनों का एंगल सेम है, साइन ओमेगा टी, सो दे बोथ आर इन फेज. सो व्हेन वोल्टेज इज मैक्सिमम, करंट इज मैक्सिमम, वोल्टेज इज मिनिमम, करंट इज मिनिमम. सो आई टोल्ड यू दिस स्टफ. सो ये कंपेयर करना होता है हमें. एसी सर्किट्स में हमें वोल्टेज का और करंट का इक्वेशन कंपेयर करना होता है कि क्या रिलेशन फॉलो करते हैं. क्योंकि देखो ओम्स लॉ हर जगह ऑबे नहीं होता. So we have to follow, V is equal to IR is followed, but exactly the proportionality is not followed, which is Ohm's law. So we have to see the relationship between current and voltage. And that's why I was doing all this stuff that you had just seen. This all stuff I was doing क्योंकि मैंने देखा कि E is equal to E naught sin omega t है, तो करंट की क्या वैल्यू आएगी. So everything that I did here was to find out the value of current. So now, anyway, this is the equation. After that, I is equal to minus E naught upon omega L. There's a formula. Sine of minus theta equals to minus sine theta. Okay. Sine of minus theta equals to minus sine theta. This means sine, if I take the minus sign from here, it will become omega t minus pi by 2. ठीक है. So this will become sine of minus theta. So this negative will be taken outside here and minus minus will become positive. Now again you will be thinking that why I have done this. क्योंकि मुझे फेज कंपेयर करना है. देखो E is equal to E naught sin omega t मैंने अप्लाई किया था. अब ओमेगा टी में कितनी वैल्यू प्लस हो रही है या कितनी वैल्यू माइनस हो रही है, मुझे ये चेक करना है. ओमेगा टी में कितना चेंज आ रहा है. सो ईदर इट इज ओमेगा टी प्लस पाई बाय 2 और इट इज ओमेगा टी माइनस पाई बाय 2 और ओमेगा टी माइनस पाई, ओमेगा टी माइनस समथिंग, ओमेगा टी प्लस समथिंग. ओमेगा टी में कितना चेंज आ रहा है, इसलिए मैंने ये सब किया सो दैट आई कैन गेट एन इक्वेशन ऑफ दिस फॉर्म. क्योंकि अब मुझे पता चल गया कि मैंने ईएमएफ तो अप्लाई किया था इस फॉर्म का, विच वॉज हैविंग एन एंगल साइन ओमेगा टी. So current is sin omega t minus pi by 2. So it means if the voltage is like this, जो करंट है ना वो उससे पाई बाय 2 लैग बिहाइंड करेगा. इट मीन्स करंट का जो फेज होगा ना वो कुछ ऐसे होगा, वो पाई बाय 2 लैग बिहाइंड करेगा. ये करंट की वैल्यू होगी. यानी ये दोनों इन फेज नहीं है. These two things are out of phase actually and they are 90 degree out of phase. कि अगर वोल्टेज ये इक्वेशन फॉलो कर रही है, करंट कौन सा फॉलो करेगा, ये फॉलो करेगा. इस इक्वेशन से ये प्रूव होता है कि जब ईएमएफ 0 होगा करंट होगा, ऑलरेडी होगा. जब ईएमएफ मैक्सिमम होगा तो कैसे आएगा ये, So what are we getting? I am drawing it again, the earlier one was wrong. So this is the waveform for voltage. सो करंट इससे 90 डिग्री लैग बिहाइंड कर रहा है, यहाँ से स्टार्ट हो रहा है ये यूं. एक तो ये कम होगा पहली बात तो वोल्टेज से, कुछ इस तरह से. सो 90 डिग्री लैग बिहाइंड एंड देन व्हेन वोल्टेज इज मैक्सिमम करंट इज जीरो. ठीक है, व्हेन दिस इज लाइक दिस then the current has some different value, so it is actually out of phase. So you need to understand this. So waveforms are different. And secondly, if you draw the phasor diagram, if this is E naught, so current is actually, this is omega t, current is lagging behind, so it will be shown in the negative side because it's lagging behind by 90 degree. So it means, what are we understanding from this? That whenever AC circuits contain inductance only inductance, then this is the behavior that we see. Also, current had an equation I is equal to E naught upon omega L sine omega t minus pi by 2. If you see only this part and compare it with I is equal to I naught sine omega t minus pi by 2, you get that I naught has this value, but current is equal to EMF upon something. Now that something should be resistance only, क्योंकि actually में ऐसा ही होता है, current is equal to some voltage upon some resistance. R नहीं है तो क्या हुआ, but omega L तो है. तो ये omega L जो है ये resistance ही एक तरह से, इसके units भी ohms हैं. लेकिन ये वो रेजिस्टेंस है जो न्यू रेजिस्टेंस बनती है जब आपके पास सिर्फ इंडक्टर होता है, और इस रेजिस्टेंस को हम डिनोट करते हैं एक्सएल से. एक्सएल मीन्स, नाउ दिस हैज अ रेजिस्टेंस विच इज नोन बाय द नेम इंडक्टिव रिएक्टेंस. इंडक्टिव रिएक्टेंस. What is this inductive reactance? This is a special type of resistance which emerges when inductors are connected to AC source. When inductors are connected to AC source, and XL is equal to omega L. Now omega L, XL is equal to 2 pi nu L. So this is a type of resistance जो आती भी सिर्फ तभी है. देखो आपने इसको इलेक्ट्रोमैग्नेटिज्म में नहीं पढ़ा, आपने इसको इलेक्ट्रोमैग्नेटिज्म में नहीं पढ़ा क्योंकि इलेक्ट्रोमैग्नेटिज्म में आपने बैटरी कनेक्ट करी थी. इफ़ यू रिमेंबर, यू कनेक्टेड इंडक्टर विद अ बैटरी, वहाँ ऐसी कोई रेजिस्टेंस नहीं आई. तो एसी सर्किट जो होता है ना, वो बार बार अपना करंट चेंज करता है. सो उसकी वजह से वाइंडिंग्स में एक न्यू रेजिस्टेंस डेवलप हो जाती है विच इज़ नोन एज इंडक्टिव रिएक्टेंस, लाइक दिस. सो इन डीसी, न्यू मीन्स फ्रीक्वेंसी, कितनी फ्रीक्वेंसी से करंट ऑल्टरनेट कर रहा है. सो न्यू इज इक्वल टू 0 फॉर डीसी बिकॉज करंट नेवर अल्टरनेट्स इन डीसी सर्किट्स. सो न्यू इज इक्वल टू 0 इन डीसी सर्किट्स. सो एक्सएल इज इक्वल टू 2 pi nu L, that also is 0. This means inductor offers no resistance to DC direct current, but whenever there is alternating current, then alternating current flows with some frequency at least. So that's why the inductor offers some resistance to alternating current, and that resistance is XL. So this is the study of AC circuits which contain inductance only. So what have we studied? That whenever a coil, solenoid, is connected to an AC source, the current and voltage are out of phase. Current lags behind voltage by 90 degree angle. So if the voltage follows the maximum, the current is 0. If voltage is 0, the current has some value. So this means they are out of phase. This is point number 1. Now point number 2. In AC circuits, if inductor is connected, a special type of resistance comes into play. That resistance is dependent on the frequency कि आप कितने frequency से alternating current को vary कर रहे हो. ठीक है. So that means that resistance is inductive reactance, a kind of resistance which comes only when inductor comes is connected to AC source. ठीक है, सो आती भी इंडक्टर में ही है और आती भी एसी सोर्स के साथ ही है. 2 pi nu L, it has the units equal to ohms only. So after that, remember that since nu is equal to 0 for DC, so XL is equal to 0 for DC. So there is no resistance that an inductor offers for direct current. Okay, so this is all the discussion about AC circuits.